Those of you who are joining this session, please go ahead and go to joinpd.com and enter the code that you see on the top right, mziapt. This is a joint problem solving session where you'll be seeing the slides on WebEx, hearing the audio and video on WebEx, and you'll be actually solving problems that I give you and entering the answers on joinpd.com. So go to another browser window, go to joinpd.com and enter the code that you see on top, mziapt, and you'll be able to access that. Go ahead and do that if you're in this meeting. Hello, everyone, and welcome to this problem solving session for week 9. So you have to participate in two ways. One is join on WebEx by clicking on the link that would have been sent to you, and also go to joinpd.com and put in the code that you see on the top right, okay, mziapt. All right, you have to do both of these. Any question I ask, I'll give you about 5 to 10 minutes to solve so that you can sit down and solve. Have a notebook and pen ready with you. Once you're done solving, you can put in your answer on joinpd.com. Okay, the WebEx chat is to be used only for questions and doubts you may have on these problems. The answer to the problems themselves have to be given on joinpd.com. Okay. So I think those who have done these sessions before will know these instructions, but I believe there may be people who are new who need reminding. Please keep your audio on mute always and participate through joinpd.com. We'll start in another 4 minutes or so, 7:30. All right. Good evening, everyone. We're about to get started. It's only a minute to go for 7:30, so we're going to start momentarily. Let me remind you once again. You have to join on WebEx for the audio and for the screen share, and you have to go to joinpd.com and enter the code mziapt, and you'll be able to answer questions that are asked in this session. Have a notebook and pen ready for solving the problems. These are similar to the graded assignment questions in week 9, so you should get a head start on solving the problems in the graded assignment if you solve the problems given in this session. Okay. Depending on the problem, you may get 5 to 15 minutes allotted, and then I will discuss the solution. Okay, and the WebEx chat is to be used for any questions you may have on the problems or any doubts you may have. All your answers have to be put on joinpd.com. Do not put your answers in the WebEx channel. Okay, so we're going to get started. The first, I usually do like a couple of screenshots. So this is how your screenshot will look when a problem is put up on the slide here. On joinpd.com, you will get an additional box where you can enter the answer. Or if you're on your mobile, you have to click on answer question and then you can answer. And there's no submit or anything. You just give the answer and it gets submitted. Okay. So this is what you need to do to participate. Do not put your answers on the WebEx chat. Okay. All right. So this is a test problem. This is, of course, not in your graded assignment. And I just put this question here for you to check whether everything is working. So you can go in and put your answer. And this screen on joinpd.com, you should see enter a number. You can enter a percentage of what do you think are the chances of India getting a draw in the first test. For those of you who are not following, today was day 4 and at stumps, India was 39 for 1 and the target is 420 on a last day pitch in Chepauk. So that's the story. What do you think are the chances that India will draw the first test? Of course, this is just a test problem for you to check and make sure that you can enter the numbers. I'm seeing a few responses. There's also a chance for people who are coming in late to get warmed up. Okay, somebody's saying there's even a chance for winning. Yeah, of course, I'm not asking the chance for winning. You can factor that into the equation that you have, and you can give us a chance for the question that's asked is what is the chance that India will draw the first test? Of course, India could win as well. If you want, I mean, of course, there's only one number you can enter, so that's why it's the number. Okay. I'll give a couple of minutes more because people need to get used to the interface and then people have to also come in. Many of them join a little late and then miss the first few questions, which usually set the foundation for the rest of the questions, and it's difficult for them to catch up. So let's take a couple of more minutes and put a lot of thought into what will happen tomorrow at Chepauk and then answer this question. The code is on the top right that you see on your WebEx screen. On the top right, there will be a 6-letter code, mziapt. Even on the WebEx chat, some of your friends may put the code for you. You go to joinpd.com and enter the code mziapt. Okay, a few words about what week 9 is all about. The week 9 is about the logarithm function, exponential function, and all that. Most people have a certain discomfort with the log function for some reason. I mean, it's actually a relatively simple function, except that it's not as simple as x or x squared or x cubed or something, and you feel like a little strange looking at log and manipulating it, and somehow you're not sure of yourself when you do some things. So this week hopefully gives you enough practice with many problems involving log, and you'll get used to manipulating log with equality, inequality, various calculations, etc. Particularly sketching, understanding how it behaves for various values of various arguments and all that. So that's the main point of this week. So I think there are enough people now and there are enough responses. So let's just see the responses. Okay, so lots of optimists and a lot of pessimists as well. And not lot, I guess. So you see a bunch at 0, you see a bunch at 100, and the large majority is 50. I think 50 seems to be a really popular answer here. So that shows you what people in this group think. So it's a lot of people are at 50, a lot of people are at 100, 90, there's 1, there's 0.50, 2000, 100,000. Okay. All right. So I think once somebody put 100,000, I can't show you this overlay because it doesn't work. Okay, anyway, that's good to know. Lots of optimists in the group. So let's proceed to the next slide, which will have the first problem that we will see in this session, which is a very simple problem. This is a reminder. I'm not going to give you too much time. It's a very simple problem designed to sort of refresh your memory. There's a quadratic function here, very simple quadratic function, which factors into two linear terms very easily, x squared minus 5x plus 6, and you have to plot and then answer this question about the range of f of x. The range is, as you know, the values that are taken by the function. The domain, of course, is from minus infinity to infinity. When you put in the value x squared minus 5x plus 6, may not take all the values on the real line, right? So it will take only a subset of the values. Given that you have that x squared sitting there, it causes changes. So what are the range of values that f of x can take? What range values did f of x take? So that's the question. There are 4 intervals given there. Like I said, it's a refresher, so I'm going to give only a couple of minutes for you to pick the correct answer. So please answer on joinpd.com. If you have any doubts on questions, something is not clear to you, you can ask doubts on the WebEx chat. So answers are to be given only on joinpd.com. So I'll give you only 1 more minute. This is a relatively easy question. Maybe needs a little bit of calculation, but it shouldn't hopefully take too much time. Let's see. Let's see how people do. Okay, so a large majority of people who are logged in have indeed responded. So let's see the response. Won't take too much time on this. So let's see the response. D seems to be a big favorite, and at the same time, even B is a bit of a contender here. About 30 people thought the answer was B, and a large number thought it was D. Okay, so let's go back and see what the solution is going to be. Plotting quadratics, understanding quadratics is very important. There's been methods that have been discussed in class for this. So let's see how this can work. Okay, so here is a way in which I do these things. Maybe there are various other ways and quick ways that you will learn as you go around plotting quadratics. The first thing is this quadratic factors. You have to check if it factors very nicely like this. It has 2 real roots or not. When it has 2 real roots, the quadratic will have a behavior like this. Okay, so less than, I mean, you have to look at the range minus infinity to 2, and the range 2 to 3, and the range 3 to infinity. you'll see that it takes, negative, positive sign, negative sign, and positive sign. So it'll have a shape like this. It'll sort of curve upwards, right? So I think you might have seen some condition for whether the quadratic will curve upwards or curve downwards. Will it hit the x-axis once, twice, not hit the x-axis at all? For all conditions, there are so many different ways to quickly do these problems. You should get to a comfort level with quadratics. Given a quadratic, you should be able to quickly see where it will go. Okay. A few things about polynomials. When you tend x to infinity or minus infinity, only the leading term matters. When x becomes really, really large, everything else will become smaller compared to the leading term. So leading term will dominate what happens to a polynomial. So that's a good hint. Just look at the leading term, x squared, right? What will happen to x squared when x is a very, very, very large negative number or very, very large positive number? It will keep going off to a very large quantity. So it will have to sort of curve upwards. It's a very easy giveaway for any polynomial. Mahesh, can you hear me? Am I audible?
Yes, sir. Yes, sir.
Okay. Thank you. So the next thing to worry about is where will this bend happen, right? So the quadratic is going to have this bend. Where will this bend happen and what will be its value? Okay, so it could either be a peak if it's sort of, opening out downwards, or it can be, a bottom of a valley or something, the least minimum possible sort of value if it is curving upwards. In this case, it curves upwards, so it's going to be minimum, and there is a formula that you can use for finding out where this bend will happen. There's a way to establish that without too much trouble. It's basically, if you want a formula, it's minus coefficient of x divided by 2 times the coefficient of x squared. So it's sort of like a magic formula. It's easy to sort of establish this by completing squares. Okay, so this is the value of x at which this bend will happen. So for this particular case, if you plug it in, you'll get 5 by 2. So 2.5, as you can see from the plot also, is the value where that bend sort of happens. And the value at the bend is simply substituting x equals 2.5 in this equation. Okay, so if you substitute x equals 2.5, you get 2.5 minus 2, that's 0.5, multiplied by 2.5 minus 3, that's minus 0.5, so it's minus 1 by 4. So the value at the point where it bends, at the minimum possible point, is minus 0.25. Okay, so I think I have one more slide which puts out this in clear detail. So there are ways. I've just written down a bunch of formulae here in case you're lazy to plot it and figure out what it is. You can just blindly use the method here. You can quickly conclude it's minus 0.25 comma infinity. Okay, so a popular answer was B, which said 0.25 infinity. Okay, so I can see why that can happen. The 2.5, if you evaluate, you can very easily sort of miss that minus sign. You may, instead of saying minus 0.25, you put 0.25, and that is a mistake quite a few people have made. I hope that is correct. That's why fraction got the answer as B. Check your answer. Always check your answer when you do these things, and so that you don't make mistakes in calculation. Okay. So hopefully that was it was just a calculation mistake from people who answered it as minus 0.5. So if you have any questions on this, please go ahead and put it on the WebEx chat. I'm not letting people annotate on the WebEx. You can go ahead and put it on the WebEx chat, and I will pick it up a little bit later. So this is a basic important thing. You have to figure out how quadratics will behave is something very important. It will help you a lot as you go forward. It's not just an idle equation. As we learn more about linear algebra, linear models and all that, a very, very simple operation is minimizing quadratics in larger dimensions, and then that will work. Now, what is the domain of this function? So if you want domain of this function, there is no restriction on the domain. Domain is minus infinity, infinity, right? X can take any value. The domain is values taken by X. That can take any value. Y is what is limited to this. This is range, right? So the value of the function will always be between minus 0.525 and infinity. What does that mean? It means this value, this polynomial x squared minus 5x plus 6 will never be equal to minus 1, for instance. You can never get a value of x for which x squared minus 5x plus 6 will be equal to minus 1. So that's what this means when you say range. Okay. All right. So let's move ahead. This is a basic problem. I want to give a very quick primer, trying to list out most of the properties of log. Of course, it has so many other interesting properties. Here is log x base a. I'm not giving its definition. I'm just giving you the plot, and then giving a lot of properties. There is some complaint about my voice breaking. I believe it could be because of issues at the receiving end on a fairly high bandwidth line here. So Mahesh, if there is any problem with the voice, please alert me. Okay. 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 So this is log base a. You can take a to be greater than 1 if it's it cannot be equal to 1. Equal to 1 doesn't make sense for log. The base has to be either greater than 1 or less than 1. Less than 1 is not that much different from greater than 1. There's a very clear relationship between the two. So you might as well take a greater than 1. Okay. So you take a greater than 1, and if you plot log x base a versus x, you will get a picture like this. Make sure you understand this picture very clearly. It's an important picture to keep in mind. So log x works only when x is positive. Okay, you cannot have x negative. It's not defined for that. It's only for x positive. And notice how it behaves. It goes all the way to minus infinity for x going to 0. Okay, so if x is decreasing to 0, log x base a decreases to minus infinity. That's one of its very important properties. So if you can actually take some values and check it out yourself, you'll see how it works. So another way to see it is, as x goes from 0 to 1, log x goes all the way from minus infinity very quickly to 0. Okay, and then it slowly goes to infinity from there. Okay, so log 1 base a for any a is equal to 0. Okay, so these are points to remember very clearly. Okay, anytime somebody gives you a function, you're interested when it hits the x-axis, when it goes to minus infinity, when it goes to plus infinity. These are three things which will govern a lot about the function. So log goes to 0 at 1 for in all a, and minus infinity at 0 from the positive side, of course. And then as x keeps increasing, log x also increases, albeit a bit slowly compared to even any other linear or even in fact root x or anything else. It goes very slowly, and that is its utility. Okay, so log is used quite often to model quantities in real life which grow very slowly. In fact, their rate of growth keeps decreasing as x increases. Okay, so it's one of those peculiar properties of log, as it's called. A lot of people call it diminishing returns, this, that, and all that. So it's a very useful function in practice because it models phenomena that are very common in real life. Okay, quite often a lot of real life phenomena are modeled using log for that reason. Anyway, so that's some primer on log. The properties down here, I'm sure you've looked at it. One of the very crucial properties is that it's one-to-one and invertible. It's increasing one-to-one invertible. Its domain is from 0 to infinity, range is from minus infinity to infinity. It's an invertible function. You can go back and forth. It versus a power x. Okay, so that's quick primer. If you've forgotten some of the main properties, we'll use many of these properties over and over again. Yes, log is an increasing function. It's always increasing. It's always increasing from minus infinity to infinity. Never stays flat or never decreases. Okay. It has so many other powerful properties. If you learn more, you'll see it's a very interesting function. Okay. Range is R. Range of log is from minus infinity to infinity. As you can see, at 0 it takes minus infinity, and slowly it starts taking all the values. It's a continuous function. It doesn't miss anything, doesn't jump anywhere, so you get all the values. Okay, it's invertible, very useful function to have. Okay, so that's a primer. Now let's jump into one of the first problems that involves log. It's not really a problem, it's just an idea on how you will plot functions composed with log. So instead of log x, supposing I give you log 2x plus 3, right? So you see the difference, right? So it's a very small change. It's not that big a change. Instead of x, I've done 2x plus 3. By the way, all these plots, many of them generated using Desmos. Sometimes I may put it down there, sometimes I've forgotten. It's generated using Desmos. Okay. So now 2x plus 3 changes something, right? Of course, it changes something. It's f of x is log base 2 of some other function now, not just x. Okay. So there's some questions about domain. Domain of log x is 0 to infinity. X equals 0 to x equals infinity. Okay, so that's the idea behind domain. Okay. So all right. So now, so if you're given log of some other function, you have to sort of focus on what happens to that function, right? So function g of x, which is 2x plus 3, it may become equal to 0. See, remember what are the critical points in log? The point where log goes to minus infinity is when x is 0, right? So what will happen if g of x is 0? When g of x is 0, log of g of x will go off to minus infinity. So you have to be mindful of where g of x is going to become 0. Likewise, you also have to be mindful of when g of x is going to become infinity, positive infinity, very large value. Okay. Third thing you have to be mindful of is when is g of x going to be positive? Because only when g of x is greater than 0, log itself is defined, right? Greater than or equal to 0 in some sense. So people usually don't include the point. I've included 3 by 2 here, so it should probably be an open interval anyway. So it's not a serious issue. So these are the three things. Anytime you look at log of a function, okay, log of a function, you need to worry about where that function will go to 0, where that function will go to infinity, and where that function will be positive. Yes, I think somebody is pointing out that I cannot include minus 3 by 2 here. If it's strictly greater than 0, minus 3 by 2 cannot be included, so it should be open interval. I apologize for that. Okay, so it's all open interval, 0, infinity. Okay. So these are the three things you have to worry about. Okay, so remember this. Anytime somebody asks you for log of a function, you worry about these things for what's inside that log. Okay, when is it 0? When it goes to infinity? When it becomes greater than 0? So for 2x plus 3, one can answer all those things very easily. You see, for minus 3 by 2, it goes to 0. Okay, so at minus 1.5, it's going to go, log of 2x plus 3 will go off to minus infinity, right? So you notice that. And then when is it positive? When is g of x greater than 0? 2x plus 3 is greater than 0 for x greater than minus 3 by 2. So from minus 3 by 2 to infinity, 2x plus 3 is greater than 0. So log has the domain of there. Okay, so it seems to be okay. So what is the difference between log and log x? I mean, so people use these things interchangeably. Don't worry too much about it. Log usually means the function log, the entire function log. Log x is one value taken by that function. Okay, so technically they are not the same, but people will use it interchangeably. People will say function log x. So when they say the function log x, they really mean the log itself, right? So technically, I cannot say whether log x is a function. Log x is only a value taken by the function. Okay, but since this is just informally, people use it equivalently. Okay, don't get too confused about that. Okay, a few more questions going on. What difference does it make whether minus 3 by 2 is included or not? So for minus 3 by 2, 2x plus 3 becomes equal to 0. While I've asked here, g of x is greater than 0. I'm not allowing equal to 0. So technically, this including minus 3 by 2, putting the square bracket there is wrong. I should put an open bracket. Okay. So 0 is not exactly included in the domain of log because log is sort of undefined at 0. It becomes it keeps going to a very large number. Okay. So hopefully that's clear. The base is also okay. So what difference does it make when I change base? Okay. So don't worry too much about the base. Okay. Any base greater than 1 is sort of equivalent. Okay. Yeah, the asymptote is at minus 3 by 2. That's another way of looking at it. Okay. So log has this asymptote usually at the y-axis. Now the asymptote shifts to minus 3 by 2. Okay. That's one way of looking at it. It's absolutely correct. And don't worry too much about the base. I mean, instead of 2, if I make it 20 also, right, the asymptote will not change, right? Forget about asymptote. It's basically the line x equals minus 3 by 2 will sort of be touching the log, but it will never really touch, right? If you think of that vertical line at minus 3 by 2, Such lines are called asymptotes. If you've not seen that before, it's okay. Okay. So instead of 2, if I change the base to 20, what will change in this picture? You should try playing around with this on Desmos or some such plotting tool. You'll see that there is really nothing much will change, right? The asymptote will not change. As in -3/2, it will go to minus infinity. That will not change. 0, it will reach at the place where it reaches 0 and all that may change. Okay, so but it'll still have the same sort of curve and then same very similar sort of behavior. Okay, so don't worry too much about the base. It will only change a few things. Yeah, these intercepts and all that, the values actually taken will change, right? But the place where it goes to minus infinity will not change. As x becomes very large, it will go to infinity. That also will not change. So the base usually is a non-entity, but when you do calculations, use the same base. As long as you use the same base, you're okay. Okay. All right. So f of -1 is 0. Okay. So you can just plug in -1. If you put x equals -1, you get log 1 base 2. Log 1 base anything is equal to 0, right? So that's the idea. So where it gets to 1 is important, and that happens at -1. Okay. So in this case, f of -1 is 0 for that. Okay. So for any base also, you can see as you keep changing base, the place where 2x plus 3 becomes 1 is the same, right? So as you change the base, where it hits the x-axis is not going to change. Where it hits the y-axis might change, I think. So yeah, I think it will change. So you look at all these things, where it changes, etc. The values taken will keep changing, but some things will not change in the log function. Okay. So my advice usually when people get confused about base is don't worry too much about the base. The base, as long as it's the same, you're okay. And the log function behaves very similarly when you change the base. Okay. All right. So let's jump into the first problem, which is slightly non-trivial. It's plotting a log of a quadratic. Okay. So we saw quadratic separately. Then we saw log of a linear function, which we saw last time. Now I have a quadratic, slightly more complicated looking quadratic function, -36 plus 20x minus x squared. And I want to plot log of that. Okay. So one of the implicit things when people write functions like this is they'll assume when that function goes negative, as far as we are concerned, we don't define log. Okay. So you just leave that aside. So only where this whatever's inside is positive, I'm going to focus on. Okay. So there are 4 choices. I'll give you a few minutes. Take your time, see if you can understand how the quadratic works, and from there figure out the range of this log of quadratic. Remember the same principles. I told you what to look for when you look at log g of x. Where does g of x go to 0? Where does g of x go to infinity? Those are the things that matter. And where is g of x positive, right? Those are the things that matter. And if you have multiple places where it goes to 0, pay attention. Then log of that will go to minus infinity in those multiple places. So you have to sort of pay attention to how that works along with the other things. Okay. So this quadratic actually factors into 2 linear factors in a very nice way. You can do the splitting of the middle term to get there. Oh, there's someone who's concerned about my privacy. Thanks a lot. Okay, let me see if I can. Is that okay? I think I made it full screen. I hope this is sort of retains my privacy. Thank you. No problem. No problem. Thanks for letting me know. No problem. About one-third of the people logged in have responded already. Please take your time. This is maybe this take a little bit more time. Don't worry about the base too much. Like I said, the properties just hold always, right? You have to worry only about the places where the quadratic goes to zero, the places where it's positive. Those are the first two things. You have to worry very clearly. Try to get a rough sketch, and then things will become clearer for you. The base will come in only at the very last point or so where you have to evaluate something. Until then, the properties don't depend so much on the base. Nearly half the people have responded. We give it a few more minutes. Responses are slowly trickling in. More than half have responded now. Okay, so last minute. I'm going to stop after this and show you the responses. You have just 1 more minute left. Okay, so more than two-thirds have actually responded. So now is a good time maybe to show you the responses. Let's see. D is the number one choice, but A and B also seem to be a bit popular. Minus infinity, comma 64 and 6, comma infinity. I can see where the confusion on A comes from. And B also maybe is a bit confusing. So let's see the answers. So let me show you the answer. D is the correct answer. Minus infinity, comma 6 is the correct answer. So let's see how to go about doing this. So first thing is, this is log of a function, log of g of x. So we need to worry about the properties of g of x first. And like I said, g of x factors first. You can see the factor quite easily. Minus x minus 2 times x minus 18. I believe that's correct. That's the factorization. So you can quickly answer that g of x becomes equal to 0 at x equals 2 and x equals 18. Okay. So you immediately see there's this possibility of minus infinity for this function at 2 points. And then where is it positive? It's positive when x falls in the range 2, comma 18. Okay, that's another thing you can check. When x is greater than 2, the first term is positive. And when x is less than 18, the first term is positive, second term is negative. If you multiply, you get negative, minus of that becomes positive. So this function is positive when x is between 2 and 18, and it's negative in the other ranges. You can check that if x is less than 2, it's negative. If x is greater than 18, it's negative. So this is the point range which is interesting to us. So the range of interest is 2, 18. And then at 2 and 18, you're going to have these vertical asymptotes as described going off to minus infinity. Now, does g of x go to plus infinity? Not really, right? So it's one of those opening downwards type of, quadratic. It goes to minus infinity slowly on both sides. Maybe not that slowly, but it goes off to minus infinity on both sides, but doesn't go to plus infinity. So that's the picture. And then here's a picture that I've drawn here on a graph for you. If you look at the range 2 to 18, it will look roughly like this. Okay. So in these kind of cases, when you take log and it's not going to infinity, it's interesting to find the peak, right? So you have to find out where the bend happens, and then for that you use the formula. So the bend, what is the formula? Negative of the coefficient of x divided by 2 times the coefficient of x squared. So bend will happen at 10. The formula tells you the bend happens at 10, and the value of that is 64, right? So you plug in x equals 10 here, you get 64. So you can see 64 is the value. Okay. Now you can take log base 2 and you can quickly see what will happen. Notice how the plot looks. No, it's log looks so much flatter, right? It's almost like somebody took a hammer and beat down the original function to get the log, right? So at 0, so at 2 and 18, there are asymptotes at 0. It just quickly drops down to 0. And then it sort of slowly goes off all the way to plus 6 when you take log. And why is it plus 6? Log 64 base 2 is 6. Okay, 64 is 2 power 6. So the evaluation comes to 6. Like I said, up to these properties, the log base of the log played no role. And only when you had to evaluate the peak value, it played a role and gave you the 6 instead of 64. Some people did not take the log and gave the answer as minus infinity 64. That is the range for the quadratic. When you take the log, the range becomes minus infinity to 6. Okay, that's the answer. Hopefully this was clear. The working out has to be carefully done. And in fact, some people will argue that I don't need all these things to find just the range. If I want to just find the range, I don't need to plot or anything. Yeah, you can just quickly find the peak. And then from there, you can do that. Why does it start from minus infinity? The reason is, there is points where you can get to 0, right? When x is going to 2 from this side, it will slowly start hitting lower and lower and lower numbers. Like for instance, 2.001. Supposing you put x is 2.001, right? You'll see x minus 2 is 0.001. X minus 18 is something negative. So minus into minus, it becomes plus, and you'll get a very small number. So as you keep approaching x to 2.00001, 2.000 all the way 1, as you keep doing that, you see that this g of x is going to go closer and closer to 0. So you see that's why this plot happens, right? So as you near 2, you go to minus infinity with the log, because g of x itself is approaching 0 there. So it will go to minus infinity. That's true for any base, right? So that's what's important. Same thing will happen as you approach 17, approach 18 on the right side. You go to 17.999, 17.999. Keep doing that. You'll see you'll keep g of x will keep tending to 0. As it tends to 0, you'll see you'll get you'll go off to minus infinity. That's all that's happening here. Okay. Once you understood the quadratic, taking the log is usually very easy. Okay. So okay. So there's a question about so this log function is not increasing. That is true. So when people say log is increasing, you should be very careful. They mean log x always, right? The log function is assumed to be log x, right? So log x versus x is an increasing function. If you change that x to something else, there's no guarantee on what can happen, right? So many things can change. The domain changes, the range changes, the fact that it's always increases also changes. Okay, so this is a composition. So log 2 of some other function, it's a composition of two things. It's not the same as just log x. Okay, so this is very illustrative, I think. is this positive? No, no, no. This log of this goes negative. It's all goes all the way to minus infinity. It seems like it doesn't, because in this plot, this is like a linear plot, no? So you can't see 2.001, 2.00001. If you can actually distinguish those things, you'll see it will go negative. So it's instructive to sort of zoom in close to zero and do a log spacing plot on the x-axis. Okay, so you'll see the negative values. Okay. So these are difficult to imagine. Yeah, x equal to 2 and x equal to 18 are vertical asymptotes. That's also correct for this function. Okay, all right. We're running out of time. We're going to see one more problem. And this problem is also a plot of log of quadratic. But this quadratic is a bit different from the previous quadratic. Okay, but before that, let me also give you a bit of a thinking on increasing, decreasing, and log. Okay, so this also is important to remember. Okay, log x is 1 to 1 and increasing. Okay, domain is 0 infinity, range is minus infinity to infinity. So if you have an equation, you can comfortably sort of take log on both sides. You won't lose anything in the equation. Okay, so if x1 is x2, x1 equals x2, and x1 and x2 are in the domain, you can comfortably take log. Log x1 will be equal to log x2. You wouldn't have lost anything. Okay, something wouldn't have been lost because it's all 1 to 1 and it's comfortable that way. The reverse is also true. If log x1 equals log x2, then x1 has to be equal to x2. So both of these are true. You can take log on both sides of an equation. You can also take log on both sides of an inequality. Okay, so if you have x1 less than x2, both x1 x2 are in the domain of log, you can comfortably take log x1 and it will be less than log x2. Okay, so that will be true. So like reverse is also true. If log x1 is less than log x2, then x1 will be less than x2. And instead of less than, you can put less than or equal to, it will still be the same. Okay, so you can take log on both sides of equations, equalities and inequalities, but remember the condition. Just make sure that both are comfortably in the domain of log. It's true only when that is true. So if something can go negative, then there'll be a problem. Okay. Uh, okay. So this is correct. So you can take log on both sides and things will work. Okay. So remember log x, when I say log x is 1 to 1 increasing, I mean the function log x versus x. It's not log, minus 36 plus 20x plus x squared. It's not that function. It's log x versus x. That's a 1 to 1 and increasing. That's correct. Okay. All right. So this is also useful for people who are not comfortable dealing with log around equations. So you can always do that. All right. So next thing is also a plotting sort of question, a range question or increasing, decreasing sort of question. But again, it's log of a quadratic, but it's a different sort of a quadratic. It's not a quadratic with two real roots. It's slightly different. And the question that's asked is whether the function f of x is increasing or decreasing a function. Okay. So remember, log is any base. Forget about the base. Log is a one-to-one increasing function. So if the original function is increasing in an interval, log of that function will also be increasing in that interval. Okay, the original function is decreasing in that interval, then log of that function will also be decreasing in that interval. Okay, so log preserves increasing, decreasing in some sense, right? So that's what the previous inequalities told you, right? If the inequality is not affected by log. Okay. So to check whether f of x is increasing or decreasing, what do you have to do? F of x is log 10 of something, right? Right? To check whether f of x is increasing or decreasing, all you have to do is to check whether that something is increasing or decreasing. So here, it's enough if you check if the quadratic is increasing or decreasing. That will give you the answer. Okay, so let me give you a few minutes to see if you can check that out. Okay, about half the people have responded. Okay, more than 2/3 have responded. I'll give one more minute, then I'll show you the responses. Okay. Okay, so let's check out the responses. Let me see, maybe a grid view here. People have said AB. AB seems to be there. Some people have said B. Some people have said A. Some people have tried to expand a little bit. A lot of people have said A comma B, A comma B, A comma B, B, C. Some people, a lot of people have just said B. They've not looked at A maybe. Okay, so quite a lot of people have said A comma B, and that's the correct answer. I believe A and B are both correct. It's like I said, it's just inherited from what's inside. So let's just quickly see what's inside. X squared minus x plus 1, it doesn't have any real roots, and it goes to infinity. Yes, when x is plus infinity minus infinity. And where does the bend happen? The bend happens at x equals half. Okay, and the value at the bend is 3/4. Okay, so these are all the points. Where is it positive? It's positive for all x, so there's no problem there. So quickly you can see, if you plot x squared minus x plus 1, it's going to open out on top, then have its minimum at 1/2, which is 3/4. It never goes negative. So that's the shape. So from there, this half you can see becomes a critical point. So if you look at the interval half to infinity, x squared plus x plus 1 is strictly increasing, and x squared plus x plus 1 minus x plus 1 is a one-to-one function. Okay, so that is that's how the property works for x squared minus x plus 1. So the same property is inherited by log of that. So from half to infinity, log also, if you plot it, you'll see that it's one-to-one, and it is increasing function. Okay, so this is how the plot will look. It's quite easy to just quickly argue just based on what's inside the function. Okay, why is it one-to-one? The same reason, log can be exchanged out of an inequality. Okay, no. Okay. So think about the range here. Okay, the domain. Domain is very important. Go back to the previous question, previous slide. You see the domain is 0.5 to infinity. It's not the whole minus infinity infinity. Okay, the domain is 0.5 to infinity. F of x is a one-to-one function in the interval 0.5 to infinity. Okay, so you look at only 0.5 to infinity. Forget about what is left of what is left of 0.5. That doesn't exist. Then you have all these properties. Okay. Someone asked about asymptote and all that. So those things are not there, right? Because x squared minus x plus 1 never becomes equal to 0 for any real x, right? So you will never get 0, which means log of x squared minus x plus 1 will never go to minus infinity in the same way as log x does at 0. So you will not have asymptotes for this kind of function. So once again, don't think of log of anything as having the same property. See, log of some function reflects a lot of properties of that function. Okay, so everything depends on what is inside that function. Okay, So remember that. Okay. How is it a one-to-one function? Okay, so if you look to the right of 0.5, x squared minus x plus 1 is 1-to-1. Okay, so if you look at the domain to the right of 0.5, x squared minus x plus 1 is 1-to-1. Okay, that's the first thing. Do you agree with that? If you agree with that, then taking log doesn't affect those properties, right? Taking log keeps 1-to-1 as 1-to-1, keeps increasing as increasing, keeps decreasing as decreasing. It doesn't change any of those properties, so that's enough. Okay. Yeah, x squared minus x plus 1 cannot cut the x-axis, and it's opening out upwards, so which means it has to be positive throughout. Okay, so this is just a property of the quadratic, and I mean, so yeah, so you have to know about quadratics a little bit. This has been covered in the lecture, so go take a look. And the bend happens at, the sort of the minimum happens at 0.5, and that's important. Okay. All right, so this is log of quadratic. We're going to move on to the next question. What will be the domain be here? Okay, so see, the domain of the entire function is from minus infinity to infinity. There's no problem there. But the question asks for 0.5 to infinity. So that changes everything. Okay. If the domain were minus infinity to infinity, then things are different. But this is 0.5 to infinity. So the question becomes different. The question itself has put a domain for you. Okay. Okay, so that's the range goes from log base 10 3/4 to infinity, all the way to infinity, right? What is log base 10 3/4? It will be some mildly negative number. I mean, because see, 3/4 is less than 1, right? So log base anything of 3/4 will be negative. Okay, so you will get when I say anything, of course, anything greater than 1. So that this will be a negative number. All right. Hopefully that's clear. So the range of log base 10 x squared minus x plus 1 will be from that negative number all the way to plus infinity. Okay. Yeah. So this shows the entire curve. Somebody is right in pointing that out. You have to only worry about half to infinity. So throw the other half out. Okay. So here is a question for you based on the previous plot. When will this f of x be equal to 0? Okay. Let me see if people can quickly put in responses. When will x squared log base 10 of x squared minus x plus 1 be equal to 0? Okay, so I'm going to give only 1 minute and quickly show you. The plot itself is obvious. It's right there for you. You can quickly read it off from the plot if you want. Oh, somebody's saying complex. Okay, think about it. I don't want x squared minus x plus 1 to be equal to 0. I want log of x squared minus x plus 1 to be equal to 0. So what should x squared minus x plus? Okay, 0 comma minus 1. I'm not sure if minus 1 is correct. Never. Okay, so everybody is again confused about log versus no log, right? See, if log is not there, x squared minus x plus 1 will never hit 0. But log of x squared minus x plus 1 can hit 0. Okay, there are so see, x squared minus x plus 1 should be equal to what for log of that to hit 0? It should be equal to 1. So if you say x squared minus x plus 1 to be equal to 1, then you will get two values for x equals 0 and x equals 1. For both those values, log of x squared minus x plus 1 will be equal to 0. Okay, be careful about that. These are the subtle sort of things that log changes. Log changes a few things and doesn't change a few things. So you should be careful about what it changes and what it doesn't. Okay, so let me just quickly check the responses. Quite a few people have said 0, 1. Some people have said 1. So x squared minus x plus 1 should be equal to 0. That's the story. Okay, so we're running out of time as usual. So let's quickly go through to the next question. Here is question 4. Here is again log of another function. This time it is natural logarithm, ln, which, like I told you, don't worry anything about so anything about the base of the log, ln, any other base. Its properties are the same. So you can just use the properties and worry about the base if at all you have to do any calculation with the numbers. Okay. I'll give only a couple of minutes. This again, you have to determine only whether it's increasing or decreasing. And like I told you, log of some function is increasing or decreasing. If you want to determine that, what should you determine? You should only determine whether that function itself is increasing or decreasing, and worry a little bit about domain, etc. if you're concerned about that, just to make sure it's well defined. And then just check if the function itself is increasing or decreasing, and you'll get the answer. Okay, right? So you don't have to, the log doesn't change the increasing, decreasing one-to-one properties in the range. But find the domain, that's quite important. Okay, so people have answered. We don't have too much time. I'll give a couple of minutes more, maybe 1 or 2 minutes, and then we'll see the answers. Okay, close to 50% of the people have answered. So let me just quickly, maybe about 30 seconds more, and then I'll quickly check the answers. Okay, so the function inside is rational as in x by 5 minus 6x. So you have to sort of think about when that's going to be positive. So this numerator and denominator, you can deal with each of those separately, right? You can see when the numerator will be positive and denominator will be positive. That's one case by which the fraction can be positive. The other way is for both to be negative. Okay, so you test out both, make sure what passes, what doesn't pass, and what works out. Then you will get the range, the domain. Once you get the domain, you just have to check whether what's inside is increasing or decreasing in the domain, and then once you do that, it's fine. You'll get the answer. Okay, log will not change the property too much. Okay, so large number, more than 2/3 have answered. So let me just pick up the response. The C and B and C are in close competition. So it seems like, and also A also seems to be there. So people are sort of equally confused about what the answer is going to be. So I guess it's important that we look at the solution. So let's look at the solution. Okay, so this function x by 5 minus 6x, right? So this is a function. Okay, so you can ask, when is this function 0? That's okay. That might be relevant, right? These are things you have to worry about when you worry about log. So that's one thing. And does it go to infinity? Yeah, maybe you have to worry about that as well. So that happens as x keeps going towards 5 by 6, right? If it goes towards 5 by 6, g of x goes off to infinity, very large value, okay? So both of these can happen, something to worry about. And most important is to figure out for what x is g of x greater than 0. Okay, so it's x divided by 5 minus 6x. So you have to look at both these conditions. If you look at x being positive, right, and denominator being positive, when is denominator positive? And x is less than 5 by 6. Yes, these two together can hold, right? That can happen. if x is between 0 and 5 by 6. But the other condition actually doesn't really work. If x is less than 0 and you want 5 minus 6x to be less than 0, then x has to be greater than 5 by 6. You cannot have x being less than 0 and x being greater than 5 by 6. So this condition will not work. So this will simply not work. So the domain is just 0 less than x less than 5 by 6. So x is between 0 and 5 by 6. This is the domain. Okay. So this is the first step, and that is quite important to determine. So x goes from 0 to 5 by 6. Okay. As x goes from 0 to 5 by 6, okay, what happens to g of x? G of x goes from 0 to infinity. Okay, think about that very carefully. X goes from 0 to 5 by 6. If x is 0, g of x is 0. When x is 5 by 6, g of x is plus infinity. And g of x goes from 0 to infinity as x goes from 0 to 5 by 6. Is g of x an increasing function? That is the question, isn't it? If g of x is an increasing function, everything is settled. And how do you check that? You check that like this. Okay. You just say if x1 is less than x2, can I show that 1 by 5 minus 6x1 is less than 1 by 5 minus 6x2, right? So from x1 less than x2, I'm able to get here. You can also multiply by x1 on left and x2 on right. So that implies x1 by 5 minus 6x1 is less than x2 by 5 minus 6x2. Is that okay? So look at how we did this. You can also do it in other ways, but this is the quickest way. So you can check x1 by 5 minus 6x1 is less than x2 by 5 minus 6x2. That will sort of reduce to x1 less than x2 also. So you can check both of those, and you can convince yourself that this g of x is an increasing function from 0 to 5 by 6. So even if you take log, it will be a increasing function. Okay, so that's the question, and so the correct answer is going to be, if you plot it also, you can check that that's true, right? From 0 to 5 by 6, it's increasing, so log also is increasing. So the correct answer, as it turns out, is C. Okay, C is the correct answer. Quite a few people have answered C, but some people couldn't work it out quite closely enough. Let me just go through and see the chat if there are any function. Why not consider the case when x is greater than 0 and 5 minus 6x is less than 0? Yeah, that's the case we considered, right? So if you consider that case, you get x is between 0 and 5 by 6, right? It's the same case. Increasing function in its domain. Yes, that's the question. The question asks whether it's an increasing function in its domain. That's the only thing you can ask. No, you can't ask anything outside of the domain. Okay. I'm not talking about base being less than 1. So usually I'm talking about base greater than 1. This is natural logarithm, ln, so base is greater than 1. Okay. So domain, when somebody doesn't mention the domain, they mean the full domain. Okay. So in this case, the full domain is 0 to 5 by 6. So it's not that ambiguous, I think. So domain should be 0 to 5 by 6. And the hint also told you to find the domain and then go ahead and do it. Okay. So there's a question from Srinath, which is a bit confusing to me. When the range is 5 by 6, which is less than 1, why are you taking the values as 1 and 2? It's not 1 and 2, it is just x1 and x2. Okay, it's just variables x1 and x2. It's not 1 and 2. Okay, x1 and x2, I did not take the values of x1 and x2 to be 1 and 2. Right, so you go back and look at you can go back and look at what I did there. Okay, so to check whether it's increasing function, so 1 by 5 minus 6x1 is less than 1 by 5 minus 6x2. You have to then look at x1 by 5 minus 6x1, which will also be less than x2 by 5 minus 6x2, right? Because x1 is less than x2, so you will get x1 by 5 minus 6x1 is less than x2 by 5 minus 6x2. So from there you conclude g of x is increasing. Okay, you can also do calculus and all that if you know that, but in this class we have not been doing calculus, right? So it's not fair to expect people to know calculus at this level. Okay, so yeah, I mean, I do agree. Checking whether x by 5 minus 6x is increasing or decreasing seems difficult. The other way to do it is put x1 for x, right? x1 by 5 minus 6x1. You can say it's less than x2 by 5 minus 6x2, right? You write that down, simplify, and you'll again get x1 less than x2. You'll get that as one of the possibilities. So it'll work out like that. That's another way to do it. This is just a standard way of checking whether a function is increasing or decreasing. Okay, so so this further questions on the log. The value of log g of 0 should be 1. Why should it be 1? G of 0, see, g of 0, if you put x equals 0, g of 0 is 0, right? It becomes equal to 0. So you can't take log of 0 as such, no? You should go towards 0. So in fact, log of that will go off to minus infinity. It's not 0. It's minus 10, right? It's going off to minus 10. Think about that. Okay, so we're quickly running out of time. So let me just go through and maybe do one more question. And then maybe we may not have too much time. So think about this. There is, what is the question? Visualizing log of x squared minus x plus 1. Okay. See, the most important point to remember is log of x squared minus x plus 1 will have very similar properties to x squared minus x plus 1. So you first do x squared minus x plus 1. Okay. After that, how the shape changes when actually log happens is not too relevant. No, only the increasing and decreasing function is important. Okay, people are saying each question is tough. Yeah, I mean you have to look at it. There are these simple principles that people are using that need to be followed, right? When you take log of a particular function, only the properties of that function matter, right? Taking log really doesn't affect too much. The increasing, decreasing is not affected by log. So in this case, yeah, something like that. I think what Samit is saying is a good point. Log sort of changes the scale once the domain is set, right? It doesn't do much to the properties, but you should be comfortable dealing with what is inside. You should know how to deal with the quadratic. You should know how to deal with x by 5 minus 6x and functions of this nature, right? So you can also use other methods. I mean, if some people seem to be a bit advanced, they seem to know about calculus. It's the same. You'll get the same answer. It's not going to change just because you used calculus. Okay. All right. So this is that's that. So let's move on to the next question in the interest of time. So here's a question which is similar to something we have done in an earlier problem. It gives you a function for something, for some quantity, which is a number of people who have not heard about the rumor after t days. Okay, that's f of t. And there's a formula given, and there's a parameter k. Okay, and when you're given a formula like this, you have to find the parameter using the data given, and then use that to substitute and find the question answer to the question. Okay, so this is a problem. I think even in week 8, there was a problem very similar to this, and I hope this will get something that's this is hopefully easier for you. Okay, so there's a question on books and Desmos. So for Desmos, you just have to go to desmos.com. Okay, it's free. You can use the free account. It should be okay. You can also get it. I mean, if you want an app, there's an app also. Yeah, you can get the app also. So there's a question about log and increasing. Yes, I discussed that property of log. If you're looking at a function log f of x, and f of x is an increasing function, and if you adjust for the domain correctly, I mean, you'll find the domain correctly, and if f of x is increasing in the domain of log, then log f of x is also going to be increasing. Okay. So if you're joining late, there's a bunch of properties of log that I discussed in the previous slides. And when these are available to you and you can look at it again, it'll probably be a bit clearer. So you'll need a calculator for this, at least something that finds the natural logarithms. just pay attention to this thing about people who have not heard and people who have heard, right? See, for instance, the data that's given after the first day, so that's t equals 1, right? For t equals 1, f of 1, is it 100 or is it 9,900? Okay, yeah, be careful about that because this is a twist of f of t being defined as people who have not heard, and on the other hand, the data that's given to you is people who have heard. So for t equals 1, of course, n is given as 10,000, that's the population. T equals 1, f of 1 is given as not 100, f of 1 is 9,900. Okay, watch out for that. So from that, you can solve for k and then substitute it back for getting half. So what is half? Half f of t will be n by 2. Right? So you get a value for t. You can just give the integer, closest integer to the answer. Okay, so we'll give a couple of minutes more. We are really out of time. Yeah, so this question asks you to enter the number. So you have to put in a number, use a calculator. So yeah, you can round and give me an integer. It's okay. It's fine. Log 0.99, ln of 0.99, you can simply take it as 1, you know. It should be okay. Calculate. Yeah, minus 0.01 is particularly. Okay, so not too many people have, I think, computed, but we don't have too much time. So let's just go through and maybe one more minute I'll give you. ln of 0.5, I think, is minus 0.69 something. Okay, so about 1/3 have responded. So I think out of time. So let me just show you the response. About 70, 68, 69. That's the correct answer. Okay, 69 is probably the closest. 68, 70 is also okay. All right. Okay, so that's good. How do you do this? Again, for t equals 1, you're given that f of t is 10,000 minus 100, which is 9900. So you plug it in, you get k as minus ln 0.99. Okay, this is the first step. And the next step is just substitution. F of t is 5,000, k is this, n is 10,000. So you plug it in, you'll get t to be 69 days. Okay, so it's a relatively quick problem. So let's go through and see the next one. This is probably the last one. I just wanted to leave you in there because I think quite a few people had these questions about one-to-one, then finding inverse, etc. Here is a function which is a little bit more complicated than maybe what you're used to. 15 e power x by e power x plus 1. So this function, you have to find the inverse. Of course, the inverse is given, so I guess you know that the inverse is right there. So how do you find inverse of a function? When the function is given explicitly like this, how do you find its inverse? There is a direct method here. I hope you are aware of the method, and then you have to just manipulate and get to the answer. Okay, so it will be one of these things. It's easy to check. Okay, so there's a question on books for logarithms. So we'll see if we can find a good book and a bunch of information if we can find out, we'll share with you. So the answer to the previous question was 69. In the interest of time, I'm unable to go back to that now. You can look at the slides later when it's. Yeah, a lot of reference texts for these competitive exams like JEE, mains, and advanced will have many chapters on logarithms and properties, particularly with relevant to this manipulation. There's a questions of on sum and sum of increasing functions and sum of decreasing functions. I think that's true. So if you have, say, x1 greater than x2, and f of x1 is greater than f of x2, and g of x1 is greater than g of x2, then f of x1 plus g of x1 is greater than f of x2 plus g of x2, isn't it? And same would go for decreasing as well. So okay, so once again, about third have responded to this. Let me just quickly go ahead and show. Large bunch of people are saying it's A, followed by something else. So A seems to be really popular answer. Okay, so I think that's correct. So finding inverse is very easy, right? So you have to check if it's one to one. So maybe we'll quickly see that. But finding the inverse, you instead of f of x, you can put y and then solve for x in terms of y, right? So it's just a question of solving for x in terms of y. Okay, so once you do that, you will get the answer, and that's as simple as that. So let me just show you how it's done here. So this is how you find the inverse. For f of x, you put y, and then you just solve for x in terms of y. Okay, so you just cross multiply and simplify. You get e power x is y by 15 minus y. Remember equality, you can take log, right? You just take log x equals log ln. In this case, e is there, so base is ln. So you get y by 15 minus y. That's f inverse. Okay, as simple as that. There is this issue of checking whether it's one-to-one. So basically, how do you check if it's one-to-one? If f of x1, so you put x1 and x2 and assume f of x1 is equal to f of x2. When you simplify, finally, the only option you get should be x1 equals x2. If that is true, then it's one-to-one, right? So you just plug it in and start simplifying. Okay. So you put in x1 and x2 and cross multiply, and you'll see cancels. First 15 will cancel. Then when you cross multiply, e power x1 plus x2 will cancel on both sides. So you have to just check if e power x1 equals e power x2, and that's true, right? That's, you can take log on both sides to the correct base, and you get x1 equal to x2. Okay, so I think this is the last problem. So we're going to stop here. Option A is correct. So we've done a subset of the problems from the graded assignment. Hopefully it was clear. So hopefully this session was good for you. We're going to stop right here. So the YouTube link should be there. In fact, must have been given to you as part of the at the WebEx link and other things as well, because you can go on that. Oh, so somebody's saying many slides are left. I think those slides are just backup slides, additional slides. They're not there in the included in this. Okay, so there's the okay. So people asking for additional sessions. We'll see if we can arrange for some this time. This is what happens. So the same video is available to you. So I would suggest that you go that you go through and look at these sessions later also in a more relaxed way. I do provided most important properties of log, which are needed for solving. So it'll be useful for you. Okay. So go through the examples that we did today again in a more relaxed way. You'll sort of get the idea. So the main idea for range of log of something is whatever is inside has to be positive, right? So that gives you the domain. And then when you do the range, it works out. So if you want to see the calculation, okay, so it works like this. For the inverse, anyway, these slides are going to be available to you, so it will work. Okay, so people are going to keep asking for more and more sessions. How many more, how many ever we do? There are lots of questions on more sessions. We'll try and do. We'll see if more sessions work out. Okay, so we'll try. I'm not able to promise anything now. I'll see if more sessions can be done. Okay, yeah. So I think. Okay, so on that note, we'll end this session. Thanks a lot for participating, and have a good night. Bye-bye.